So this I think we are not covered this. The sampling of the aggregate is very, very important. So whenever you are sending any samples to the laboratories or even for our own testing, because always aggregates comes in very bulk quantities, maybe in truckloads or wagon loads like that. Or from the quarry itself, you can get the sample when you are going for approval of quarry. In such cases, sampling is very, very important. So IS 2430 is code is give us the how to sample your aggregate and how much sample to be sent to the laboratory depend upon your aggregate type. Means fine aggregate, coarse aggregate, 10 mm, 20 mm like that. So this is very important because suppose you are not done proper sampling and whatever representative sample received at the laboratories for testing is not matching your representative sample from the lot, whatever you have received, then whole mix proportioning will have a lot of issues in when you go for preparation of concrete production rather. So one is sampling in the sense when there is a pile of your aggregates are there, we have to take number of samples, maybe half of kg or one kg in number of locations at all the area should be covered from bottom to top and their circumference also. So that sample maybe around 20 or 10 to 20 kg sample, you can bring it to the laboratory. And once you got, again we have to sample reduction is required because you cannot test 20 kg sample for our whatever test we are going to do for the requirement of our concrete making. So one of the method is refill box. There is a sampling box are available with different parts. So we can pour the concrete into that and get the sample reduction till you get desired level of samples. So first we will do 20 kg, then we will get 10 kg and then 5 kg, 2 kg, then maybe 1 kg sample. We can get a representative sample from that. So that is a mechanical system where the various parts are there. You can refer this in the code how they are doing the sampling, because I am not going to spend much time on this sampling, but it's very, very important. So whenever as a QC engineer giving instruction to your technician or subordinate to get the sample, we have to properly explain him how to do the sampling, because technicians or the lab staff may not be knowing how to sample. He will go there and get the sample from one location and that may not be representative in nature. Then you will have your results may not be give a proper properties in concrete. Secondly, what is happening is your aggregates are when you are talking about 20 mm. In 20 mm you will have 10 mm also. Some amount of 4 mm, 5 mm also is there. So when you are unloading from truckload, there's a chances there's a segregation. Bigger parts will come maybe side and smaller part on the other side. So that's why that sampling has to be a proper sampling is required. Secondly, include even fine aggregate also. Suppose there is 5 mm, 6 mm aggregates are there, particle size, and some particles maybe you have around 150 micron, 75 micron. That's a very, very fine. So when you download on the stockpiles, you'll find that there is a fine and coarse aggregates are separated. So when you are batching, we have to supposed to mix this with the mechanical means. We have loader or JCB bucket. You mix it and then we can go for the production. So similarly for sampling also, we need to have a proper sampling. And once you get the sampling, one is refill box or there is a coning and contouring system, which is also explained in this code. You can make a heap, make into the 4 parts. Out of 2 diagonal, you can remove and again mix up another 2 parts and again make a 4 quarters and again opposite you take the samples. Like that you reduce the sample till you reach the desired level of sample size. That is very important. Secondly, what is happening is whenever we are seeing most of the time, one mistake people are doing is when you sample, you may get random figure. Maybe suppose weight you could take 800 grams. Sometimes you'll get 500 grams. Sometimes 1200 grams. So that is the representative sample of that particular lot. But there is always practice we are seeing most of the site. If you get 800, 850, people are adding more sample, make it 1000 grams. That is not a proper sample because you have added some material which is not come go through this process. So that is important. Your technician also, because when you make it round off, then there is a possible your calculations may very easy. I make 1 kg or 2 kg, so I have to work out percentage wise is very easy. But that is not a proper sample. One must understand very carefully what is the sampling. So whenever you go to the any lab and check their results, if the sample size is round, totally round figure, maybe 2 kg, 1 kg, 1.5 kg, there's a chances that the sample, the very remote chances we get round sample, very remote chances, maybe not even 0.1%. So whatever you do, sample, whatever sample you get, you weigh that sample. Initially, you weigh that sample and do the testing. Maybe if you are doing sieve analysis, you do the sieve analysis, and after doing sieve analysis, you add everything and see whether it is matching with your original sample. There may be loss of maybe 1 gram or 2 gram because fine dust is there sometimes in fine aggregate. It happens. It's okay, but it has to match with the original weight. So there is always practice that whenever you take a sample, you take initial weight, do the particle size distribution, take weights of each particular grade grains for the particular sieve, and add again. It has to nearly match with the initial weight. That one has to remember very carefully because sampling is very, very important. When you are producing large amount of concrete, there is the chances that if your grading is not okay, interpretive sample is not there, you may suffer with the lot of problem in fresh properties in concrete. When you talk about particle size distribution, the particles has to be represented. Then only you can blend with 10 mm and 20 mm and get the proper grading. Otherwise, if the sample is not okay, you will have issues in the concrete production later, and you will not able to find out what has happened. So at least your technicians or their subordinate or staff, lower staff, you have to teach them what is the importance of sampling. Because we have observed this whenever we are giving some instruction to the engineer, he will give instruction to go there and get the sample. He just take the bags and put some sample and get it to send to the laboratory. Once results come and you do the actual production, you will find there is a huge difference because your sample is not representative. So always remember sample has to go representative sample from the particular stock. And that sample is for testing. Those are testing parameters. What is the size of sample required on the size of your aggregates and type of aggregate is given in IS code. So that minimum has to be there. So this suppose IS says 10 kg, so at least you will have 10 kg or 15 kg. Should not have 5 kg. So that one has to ensure you make a chart of this, put it on your laboratory when you are working on this concrete and see that it should match that. Once go for testing, your IS code is there, IS 2386 part 1 to part 8. Now this, all the tests, whatever they specified are, we are not doing regularly, but certain tests has to be done regularly. Some are maybe weekly, some of the monthly, maybe some of that yearly. So that frequency I'll tell you, but it has to be made. But when the source is very new source, the new quarry is there, it is always advisable to test all the tests whatever given in the IS 383 and test method is IS 2386. So you have data of all the test results specified in IS 383. So anything goes wrong in concrete later on, you can go back and check my aggregates are meeting the requirement as per the standard. The specification is IS 383, method of test is IS 2386, part 1 to part 8. So this is frequency of testing aggregate as given in IS 4926. This you can refer this code IS 4926. This code is basically for ready mix concrete. And you must have seen most of the our projects we are using ready mix concrete. So huge amount of concrete you are producing on daily basis. So next we are getting huge amount of aggregate also. So they are given typical properties of high rate and then monitoring for low test rate. So that's what I was telling, monthly or weekly. One has to see. Once you get very consistent result, then you can go for low rate test. Initially, you have to go for high rate test, and once you get the consistent results, not much variation, and then you can go for low test rate. Now, this code also you should have copy of this IS 4926, which is for ready mix concrete. So this is all the tests mostly specified in the IS. They are given. Grading is there, specific gravity is there, water absorption, at least bulk density. These are all important for your mix design. Then silt content, quality of your material, fine and coarse also is there. Aggregate impact value, you know the quality of the aggregate, how it is resisting to the impact load. Then we have 10% fine value when the impact value is very high or aggregate crushing value is very high, then we can go for 10% fines value. Then flakiness index on the shape, flakiness and elongation both is there to understand what is the shape of material. Then chloride content, because chloride is also coming from your, suppose the sand is coming from river or your quarry getting some discharge from industries nearby. So then it is very important to understand what is chloride content in the aggregates, because ultimately it will be responsible for corrosion of your steel. Then abrasion test, mostly this goes for factory floors or road or runways. We do Los Angeles test, that is on coarse aggregate. So that has also to be tested on regular basis. Then we have soundness, see how it is standing in weather conditions. Means winter and wetting and drying cycle. If that cycle is disintegrated, then we have to see what level it is there, and their requirements are given in IS 383. But this is, see here, frequency is yearly or source change. Whenever there is a source change, you have to change it. Similarly, alkali aggregate reactivity also once in a 5 year, because once you go on blasting your rock, you'll find that there is a change in the rock type also with the depth, or there is a source change. So this one has to remember the frequency. Some of the projects where the big projects are there, like metro or other projects, they have their own frequency, but basic, when there is no frequencies available on the project size or the project specific, and also they copy this and put it on their uh, specification for aggregates. If it's not there, you can follow this, or you can follow project specification, because sometimes depend upon the project requirement, they may change this frequency of testing. This is one of the condition of aggregate. Is very important to understand when you are doing a concrete. We are getting a lot of variation in the workability levels. So this is the four conditions are there on the aggregate. Suppose you take 1 grain of aggregate, it is always going through the whole process of their conditions. One is a bone dry, the bone dry. There's no moisture in this. So this is only possible when you are doing a testing for water absorption, put it in the oven for 24 hours or constant wait, and then you wait. So initial and final you'll find what is your weight. So then there is air dry. So wherever it is lying in the open area, depending upon your temperature and relative humidity, this condition changes. Is absorption. In summer, you may get very high absorption. In winter or rains, will get this condition also, saturated surface dry condition. And sometimes with heavy rain, you will get saturated, and plus there is a water film over the aggregate. Now, here one point one has to remember is whenever you are doing design, concrete mix design, all the calculations are based on this condition, SSD. So whatever you get the mix design received from your laboratories or in the third party laboratories, all are based on this. That is what IS says. But some of the international method, they do also go on with this own dry method also. But for convenience in IS standard, it goes with saturated surface dry condition only. Now, when you are using this aggregate in concrete production, then what happens? They may be in this stage or they may be in this stage. It's not at this stage. Always this or this stage. That's why we always says you have to do water correction for your aggregates. Now we'll discuss more when you go for mix design. We'll discuss in detail, but I'll always you have to remember this figure. You can see this figure also, same figure, but in different. In this, you can see the capacity of your aggregate absorption is only from this stage to this stage. And that is constant for your particular source of material. Because that depends upon what porosity it has got. So this is absorption capacity or total internal moisture. And it doesn't depend upon the any other conditions. But effective absorption, this depends, this is air dry, depend upon your ambient conditions. Now most of the aggregates available except monsoon, you get on this stage. So whatever water you have calculated in your mix design has to be increased by this percentage, this white percentage. So whatever you added in concrete, come to this stage, it has to, aggregate will absorb this and come to this stage. So this is your stage where you are design your water content. In monsoon, or you get sometime river sand where it is very wet. So on the particle itself, there is a damp or wet, there is a film of water. That one, that is called free water. And that also we have to test it, and accordingly we can reduce from this particular water content. Then only water cement ratio, whatever is there, is remain as per the your design. So mixed proportions are given in SSD condition, that is surface saturated surface dry condition or on dry condition. But our IS says always on saturated surface dry condition. These conditions has to be understood very carefully, and we'll have to tell your technicians to understand and do perfectly. Otherwise, we have a lot of issue in concrete production. When you don't do anything on the correction and do the batching with this aggregate and this stage, this will absorb and will find within 5-10 minutes your slump has dropped drastically. Workability has dropped drastically. In these cases, often initial slump is very, very high, which is not expected. And if you make any water correction here without knowing what is the surface moisture, then we'll have a lot of issue in strength also, because This water added into water cement ratio, and that effective water cement ratio will be very high. In this case, effective water cement ratio is low. If you use this aggregate, you will find that aggregate, your concrete may have slightly higher strength, but workability may not be get to possible. So this figure always you remember. Whatever we are saying in the engineer, you keep on diary and keep it in your pocket to understand this figure. Is very important. Most of the issues, even in RMC, we get because of they don't do proper correction for moisture, and all other issues you get in concrete with only because of this. So in aggregate, I'm just taking a summary of this now. In aggregate for concrete, you have to see the mineralogy, volume in concrete, effect on strength because of the shape. Then workability also decide on size of your aggregate and grading, finishability, how you are proportioning your material, abrasion resistance of concrete, all are depend upon your aggregate. Then water requirements, as I said earlier, fine aggregate required more water, coarse aggregate required less water. Then durability, volume change, because aggregates are has minimum coefficient of expansion and contraction. So one has to understand, and accordingly we can test grading and other test, shape, and very important nowadays is your crust stone sand in this fines content in this. If you are not able to control properly, your concrete will not have issue, because we don't get natural sand now, river sand in this region. Even government also ban on this. Some area you get it, but most of the area we don't get the natural sand. So you crush the stone and make your sand with the proper equipment. That is called crushed stone sand. And the fines, if you are not able to control, your performance will go haywire. And also, it may contain lot of silt. Then admixture performance also will affect. So this is all in brief. We're talking about your aggregates. I'll just spend one or two slides on, because this is a major issue today we are facing with crushed stone sand. In detail, we are discuss about the crushed stone sand. What is the shape? What are the how to make it and get a good one. Some people are just replacing natural sand with crushed stone sand, and they get poor workability because it has got high fines. You must only see the shape, see the surface condition of the aggregate. Natural aggregate has a smooth surface, it has got crystalline surface. So amount of water film to required or paste required for the coating is high. So accordingly, high amount of fines are there that you have to adjust in your using proper admixture. Shape of the particles, high water demand, increase in internal particle friction because they are rough in nature. So if you see in reality, it gives resistance while moving in the concrete itself, and you will find not very good concrete. So that, and concrete become harsh in the no cohesion. So your aggregates will go away from the paste. So that is not good concrete for quality structure. How to overcome these problems? Use appropriate admixture. Some amount of mineral admixture we can use. This will cover now in future. What is the mineral admixture? One is chemical admixture, one is mineral admixture. So you can supplement this fine with this using concrete, of course within the limits of IS code. Then proportioning of fine to coarse ratio is very important to see the how you proportioning your fines and coarse ratio to get cohesive mix. This is same. Use of proper admixture to get increase the dosage, because admixture is water demand increases, you may require more admixture. Needs to modify, we increase the cohesiveness, because some of the admixture having polymers, it gives very good cohesiveness also, other than water reduction. Sometimes you can use um, viscosity modifying agent also to get more cohesiveness. And then that will, when you cover admixture, we'll discuss on that in detail. And then reduce in bleeding, and take care about high water demand. So the capability of your admixture plays major role to get good quality concrete. So this is what we have learned. Zone 1, because sand comes in zone 4. 1, 2, 3, 4. Zone 1 is coarser, then fine, then another fine, and this is more fine. So zone 1, 2, 3 is advisable to use in concrete. Zone 4 is not advisable, but where the location where the sand is not available, then after testing only it is allowed to use as a zone 4. Ideal zone for the concrete is zone 2. But you sometimes you may not get zone 1. You get zone 1 and zone 2 combination, or zone 2 and zone 3 combination. So when you do the particles distribution, you will understand which zone it is. And we have discussed earlier, the material which is passing 600 micron decides the particular zone of sand. When you refer our earlier presentation, you understand. Or you can refer to IS 383, how they define the zone 1, 2, 3, 4. So 1, 2, 3, 4 is important. Generally, for good concrete, we are advising to go for zone 2. This is what concrete you get if you are not adjusted properly. See here, it's very bad concrete. Some bleeding is there. Some few photographs, I'll just show how the concrete looks like if you are not designed properly. And if you this concrete you try to pump it, you will get pump choke ups. So it is not good concrete. See, this is also, you can see the cement paste. But this is, you can say, same material. If you design properly, you get like this. See this one, and you can see this one. So whatever is desirable is like this. So that is your concrete technology's role. How I can proportioning the material, how I can decide the admixture to get very good concrete, cohesive concrete, where I'll get very good finish, very good durable structure, and this. So one has to understand and try to design such a good concrete. So this is just comparison, crust stone and grit. What is the difference? Majorly we can see here 75 micron passing is varies from 5 to 10%, and here 10 to 16%. So that's why we are not advising to use grit or stone dust for good quality concrete, because there is no control over the fines. Sometimes you get 10%, sometimes you get 60%. Then you will just imagine how much amount of water demand will be there in the concrete. Here see gradation, consistent and controlled gradation you will get, and here inconsistent, no control, because it is a waste. Here shape also you see, it is a cubical one, is a flaky and elongated. Then water demand is moderate or high, but it is very, very high. Packing density you can improve, and then it has poor packing density, because we have got coarser material, you have got very fine material also. So we don't get good packing density, and then we'll have more cement you have to use. So lacking in fines, natural and crust stone sand. Earlier was crust stone sand and grit, because there is a confusion in this till today. So engineer has to understand which is the stone dust or grit and which is the crust stone sand. Crust stone sand which is coming from the properly designed equipment, and this is the when they do normal crushing of 10 mm, 20 mm, out of that lot of dust is generated. So there is no control over the fines. So this is the stone dust. One has to remember very carefully about it. And when you get natural sand and the cruststone sand, then here lacking in fines, especially in Mumbai, now you don't get this is the, but wherever you get, you dredge the sand from river, you will find fines are lacking. Your surface is smooth, your rough and crystalline surface. So there you need water demand more. Here rounded, good for pumping, but here also interparticle friction is high. So that can be overcome by using proper mineral admixture. Less water demand, high water demand. This can be overcome by using your proper admixture. Summary. So most important properties is manufacture in the sense cruststone sand, shape, control fines, control gradation, packing density, low clay content, and no soft particles. That one has to remember. Limitation of cruststone sand, proper selection of rock, because you have disintegrated or secondary rock, you may not get good quality sand because it will generate a lot of fines. So when you put a crusher, you have to see which input is there for the making sand. Selection of equipment is very, very important. Then there's the further processing to remove. How do you remove fine? You have air classification system or your water cleaning system. In water cleansing system also we have to understand that your fines, whatever desired level is required. You should not wash away all the fines. Water cleaning system should be very, very effective. Without losing fines, we can have a better sands. And there is a dust control also. We have to dust pollution is possible. So that can be controlled some using some dust filters in this system.